Hello and welcome back to Algebra 1 with Miss Betsy. Today we're going to be investigating how we can use quadratic equations to solve word problems. The examples that I'll be using today come from the second edition of this text, which is Algebra 1 for Christian Schools, published by Bob Jones University Press. Doesn't matter what text you use if you're in college or if you're in high school. If you're interested in seeing some worked out examples of using quadratic equations in real life word problems, this is a good video for you to watch. So let's, however, if you are trying to follow along with the text that I have, I'm on section 11.8 and I'm on page 472. So let's go ahead and pray, see what a lame joke is, and get started. Father, I thank you that you are with us always. I thank you that you love us. You love us beyond description and without measure, and we're so grateful for that. Father, help us to be able to comprehend the material placed before us and help me to speak clearly. In Jesus' name, amen. So, I wonder if you can tell me what you would call a cat who ate a lemon, other than crazy. What do you call the cat who ate the lemon? Well, you call him a sourpuss. So, the first example that I want to talk about today is one that is very much right out of real life. It's a carpentry example. Beginning on page 471, we have this problem presented to us. A carpenter wants to fit 3 boards together to form a right triangle to use as a brace. Right triangles are perfectly strong construction, shapes, and they're used all of the time for bracing and construction. Now this triangle here, the hypotenuse must be 3 feet longer than one leg and 5 feet longer than the other leg. So what are we going to need to do here? We need to find the measurements of these 3 sides of the triangle. And how in the world are we going to do this? Well, first off, let's go ahead and sketch this little right triangle here and see what we know about right triangles. Well, right triangles obviously have a right angle in them. They have 2 legs of the triangle, and they have the hypotenuse of the triangle. The hypotenuse is the side of the triangle that is directly opposite that right angle, and there's a very useful theorem, it's called the Pythagorean theorem, that allows us to solve problems like this because there is a relationship between the legs of the triangle and the hypotenuse of that triangle. And what that Pythagorean theorem tells us is the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse. So we use the Pythagorean theorem all of the time in real life problems. So what do we have to do if we're going to solve a word problem? Well, first we have to identify we have to read it. We have to figure out exactly what they're asking for. And then we have to identify what our unknowns, what our variables are going to be. Well, we need to find out the 3 different lengths of the boards that this carpenter needs to make. And our problem tells us that one leg of the triangle is 3 feet longer than that's not right. The hypotenuse is going to be 3 feet longer than one leg and 5 feet longer than another leg. So you might think at first, okay, well, I'm going to have x, I'm going to have x plus 3, and I'm going to have x plus 5 be how we set up our variables. You know, x is the hypotenuse, x plus 3 is one leg, x plus 5 is another leg. Well, got a couple of misinformation steps here, misunderstandings that are going on. First off, x, let me just write this down. We're going to say that x is the hypotenuse. What do you know about the hypotenuse of a triangle, of a right triangle? The hypotenuse is the longest side of those 3 sides. But the way we have this definition set up, the way we've defined our unknowns, the hypotenuse is actually the smallest side. So it's a little bit, not misleading, but it's a little bit tricky when you read the hypotenuse must be 3 feet longer than one leg, 5 feet longer than the other leg. So if we take the hypotenuse still as being our variable that we're finding, rather than be x plus 3 and x plus 5, we're going to have x minus 3 is equal to one leg, and x minus 5 is going to be the length of the other leg. The reason for that, if the hypotenuse is longer, then the leg by definition has to be shorter than the hypotenuse. So we start with the hypotenuse, we subtract 3, that gets the first shorter leg. We start with the hypotenuse and we subtract 5 to give us the length of the longer leg. Now, where are we going to substitute these variables? What sort of an equation are we going to come up with? Well, we're going to simply use the Pythagorean theorem. A squared plus b squared is equal to c squared. A and b are the legs of the triangle, so we have x plus, see I did the plus, x minus 3 quantity squared plus x minus 5 quantity squared is equal to x squared. And everybody look at that and make sure that you understand exactly why we're going to set up that problem that way. Well, now what are we going to do? We have two squares that we need to do, two perfect square trinomials. We end up with x squared minus 6x plus 9 plus x squared minus 10x plus 25 is equal to x squared. Now we go ahead and collect like terms. 2x squared minus 16x plus 34 is equal to x squared. We want to go ahead and set this equation so that the entire polynomial is equal to 0. So we need to subtract an x squared from both sides of the equation. X squared minus 16x plus 34 is equal to 0. Now, how are we going to go ahead and solve this equation? Well, the first thing we want to do is, can we factor it? How do you what are some possible combinations of factors for 34? We can say 1 times 34, and we can say 2 times 17. Obviously, these give us a product of a negative 34 if one of the factors is negative, but when you add them together, the best we can do is come up with a negative 15, and we need a negative 16 for the coefficient of this first degree variable here. So, we can complete the square. Who wants to do that? What are we going to do? We are simply going to take these values and use our quadratic formula. Now, because of the limitations of my video here, I'm going to have to erase this. So before I do, we have our Pythagorean theorem, and we have to have values for a, b, and c. So a is equal to 1. B is equal to a negative 16, and C is equal to 34. You remember that with the quadratic theorem, the quadratic formula, I'm sorry, we're going to use the coefficient of the x squared term is A, coefficient of the x is B, and our constant term is C. So I have that information written down over here so we don't forget it. I'm going to erase this portion of the problem. Do not erase it on your homework. You need to show me all of your work. What's our Pythagorean? Our Pythagorean theorem is a squared plus b squared is equal to c squared. Our quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. What do we do now? Simply substitute in the values for the variables, making sure to enclose those values in parentheses. We now have x is equal to the opposite of a negative 16 plus or minus the square root of negative 16 squared minus 4 times 1 times 4 times a times c times 34. All of this is divided by 2 times 1. And now we're simply going to go ahead and carry out our operations here. So we have x is equal to 16 plus or minus the square root of 15 squared is 225, 16 squared and negative 16 squared are both equal to 256, minus 4 times 1 times 34, 4 times 4 is 16, 136. The square root of 256 minus 136, all of this divided by 2. X is equal to 16 plus or minus the square root of 120 divided by 2. Now you cannot just cancel 2's from 16 and 120 yet. We want to go ahead and simplify that radical. Are there any perfect powers under there? Yes, there are. We have 4 times 30 is equal to 120. 4 is a perfect square. 30 is equal to 5 times 6. Nothing you can do there. So x is equal to 16 plus or minus square root of 4 times 30 is 2 times the square root of 30. Everyone all right with that? 16 plus or minus 2 times the square root of 30. All of this divided by 2. Let me make sure. Now we can cancel. We have 16 over 2 plus or minus 2 times the square root of 30 over 2. We end up with a value of x is equal to 8 plus or minus the square root of 30. And I don't remember my units. It was inches or feet. It was probably feet since they were using a brace. This is feet. So we have 8 plus or minus the square root of 30 feet. Now how useful is that to you? You're building a brace. That is not useful to you in the least. So what do we have to do now? Well, something that I didn't read is that our instructions asked us this. They said, find the measurement for the sides of the triangle needed by the carpenter. Use the Pythagorean theorem and approximate your answer to the nearest hundredth. Going to approximate it. Going to use our calculator to come up with a value for 8 plus or minus the square root of 30 feet. Once again, make sure that you understand the work that I've done here, and I'm going to erase the board. When you put the square root, plus or minus the square root of 30 feet into your calculator and you've added 8, these are the values that you end up with. I'm simply going to copy them out of the text because you guys know how to do that. We end up with x is approximately equal to 8 plus or minus 5.48 feet. 8 plus or minus 5.48 feet. We have two possible values, two possible solutions. Remember, you're going to have two possible solutions whenever you solve a quadratic equation. Sometimes they'll be identical solutions, but typically they're going to be, I said sometimes they'll be identical, they won't, because when you're taking the square root of something, you're always going to have a positive root and a negative root. We have two possible answers now, and we have 8 point. We have x can either be equal to 13.48 or 2.52 feet. Now, don't get so caught up in the work that you forget what you're looking for. What are we looking for? We're looking for the hypotenuse. We have two separate choices for the hypotenuse, 10.5 feet or 2.5 feet. 13.5 feet or 2.5 feet. And I can already tell you that if you're doing a brace, it's not common that you're going to be having a brace that long with the information that they've given to us. But let's just say you don't have any background in building. How in the world are you going to know which one of these is the correct answer? They're both positive. Well, over here, we left this information, we left our variables. We said let x equal the length of the hypotenuse, let x minus 3 equal the length of one leg, let x minus 5 equal the length of the other leg. What happens here if we subtract 3 and then we subtract 5? You end up with a negative number. Can you ever have negative length in the world that we live in? No. So 2.52 cannot be the length of the hypotenuse. So the length of the hypotenuse is approximately 13.48 feet. One leg is approximately 10.48 feet, and other leg is approximately 8.48 feet. These are the lengths that your carpenter is going to need to cut those pieces of wood. And 0.48 feet is not meaningful when you're measuring. You have construction calculators where it will give you the answer in fractions of inches, feet and inches. Or you could go through and come up with the meaningful answer here. But this is approximately equal to 13 feet 5 3/4 inches. But I'm perfectly satisfied for you to come up with the 2 decimal answer, because it says approximate your answer to the nearest hundredth. But if you were actually measuring this, if I were out there helping my husband build something and we wanted to do a triangle brace, he wouldn't tell me 13.48 feet, Betsy's what you need. He would say, hey baby, would you cut it 13 feet 5 3/4 inches? So these are meaningful answers here. 10 feet 5 3/4 inches, approximately 8 feet 5 3/4 inches. So you see that there is quite a lot of work involved in solving this problem, but I really think it's more lengthy than it is difficult, as long as you understand the relationship between the length of the legs of a right triangle and the length of that hypotenuse. And then you have to be able to correctly define your variables. And most frequently, or very frequently I should say, you're going to end up using the quadratic formula, the quadratic theorem, to come up with your answer. And when you have the quadratic formula, you have to remember what it is. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac. All of that over 2a You have to have that internalized, and then you have to identify what your variables are. You have to go through the work and be precise and careful with your algebra, but it very much is straightforward. Don't try and eat the whole camel, eat the whole elephant in one bite. Take these problems a bite at a time, a step at a time, and I really think that you'll be able to work them successfully. So let's clean this board and see what our next problem is. We have this example too. Your dad asked you to build a rectangular dog pen. In my case, we'd be building a rectangular chicken pen that contains 600 square feet and is 10 feet longer than it is wide. How much fencing do you need to build that dog pen? I mean, this is an this is an extremely practical problem. Okay, a rectangular dog pen. The length is 10 feet longer than the width. So that's really easy. How are we going to set up our variables? We're going to say let x be the width of the dog pen. Makes sense, doesn't it? The length is going to be 10 feet longer, so x is the width. X plus 10 has to be the length. Okay, so we have the width of x, we have the length, x plus 10, and what's the other piece of information they've given us? The area of this dog pen has to be 600 square feet. Now, you have to know your formulas, you have to have an understanding of your problem. You have two formulas that I can think of that you've known and applied when you're dealing with rectangles. You have twice the length plus twice the width is equal to something, and you have length times width is equal to something. Now let's go back to this problem and think, okay, what's Dad asking us? He's asking us how much fence. So it's going to be this, plus this, plus this, plus this, correct? And what is that called when you walk around the outside of something? Well, that's what they call the perimeter. Dad wants to know the perimeter of the fence, or the perimeter of the dog pen. When he asks how much fence you need, he's asking you to find the perimeter of the dog pen. Now, have we been given anything to tell us what that perimeter is? No, obviously we have to find it. What have we been given? We have been given the area of the dog pen, which is not 600 feet, it's 600 square feet. So this area in here is 600 square feet. And we have two formulas. Which one are we going to have to use? Are we going to use 2 times the length plus 2 times the width is equal to 600? Or are we going to use length times width is equal to 600? Well, twice the length plus twice the width is the perimeter, or P. Length times width is the area. So we're going to use as our formula, area is equal to length times width, or width times length. How about x times x plus 10 is equal to 600. Area is equal to the length times the width. So the area of 600 is going to be equal to the quantity x plus 10 times x. We have, when you have an equation that's set equal, it doesn't matter what direction you're looking at that equation, and multiplication is commutative, which is why I set it up this way. What do we have to do now? We multiply. X squared plus 10x is equal to 600. We want to have this equation set up where the polynomial is on the left-hand side. set equal to 0. So we're going to subtract 600 from both sides of the equation. And we end up with x squared plus 10x minus 600 is equal to 0. Now if you'll remember what we did last time with the problem that we were solving for the legs of a triangle that the carpenter needed to build, we tried to factor, we couldn't factor the equation, so we ended up having to use the Pythagorean theorem. Can we factor this? Oh yeah. 2 times 3 is 6. 20 times 30 is equal to 600. Whoops. 20 times 30 is equal to 600. Has to be negative. One of these factors has to be negative. Which one? We have a positive 10 for our center term, so it's going to be negative 20 times positive 30. X minus 20, whoa, yes. X minus 20 times x plus 30 is equal to 0. Now we can use our zero product property that allows us to come up with two possible values. Either x can be equal to 20 feet or x can be equal to a negative 30 feet. Which one of these is correct? Well, obviously 20 feet, because you cannot have negative length. What is x? What did we say x was? X is the width of the dog pen. So 20 feet wide. What is the length? X plus 10 is 30 feet long. Now, are we completed? Have we completed our problem? We have the dimensions of the dog pen, we have the width, and we have the length. Well, let's go back. What are we asked to find? How much fencing will you need to build the dog pen? Is that the answer? No. We have to find the perimeter of the dog pen. Twice the width plus twice the length is equal to the perimeter. So we have 40 plus 60. So we need to have 100 feet of fencing to build that dog pen. So that's another example of how you use quadratic equations to solve real-life word problems. Take your time with these. These are not problems that you're going to be able to sit down and crank out the solution to in 30 seconds. But you're very capable, you've been practicing, you've been learning lots and lots of things, and you're certainly capable of sitting down and saying, oh, I understand that, so I'm going to take this theoretical math that I have, and I'm going to help use it to help me solve a real-life problem. So let me go ahead and do just one more example. This is an extra one. We have a problem here, and it says one integer is 5 more than another integer, and the sum of the squares of the integers is 193. Find the integers. This is an additional problem from the teacher's guide. So we're trying to find two integers. So the first integer and the second integer, and we're going to need to come up with a variable that will help us to, that we'll be able to use to create a formula. So what do we have? One integer is 5 more than the other integer. Okay, the first integer is x, the second integer is 5 more, so we have x plus 5. We have now defined our unknowns. First integer is x, second integer is x plus 5. What else do we know? The sum of the squares of the integers is 193. You know what's going to be easy to mistake here? You're going to want to go, the sum of the integers is equal to 193, because this is the type of integer problem that you've done in the past, and your mind is going to want to skip over. When you're reading, it says the sum of the integers is 193. But you look at it, it does not say that. The sum of the squares of the integers. So you have to square the first integer, and you have to square the second integer, and then you have to have some algebra to do. X squared plus x squared plus not 5x, x squared plus 10x plus 25 is equal to 193. Now we have 2x squared plus 10x minus, 2193 minus 25. I'm just delighted that I picked this problem, minus 25. Didn't look to 8, 6, minus 168 is equal to 0. 2x squared plus 10x minus 168 is equal to 0. And I'm thinking, ugh. What's the first thing to do? I can divide this equation by 2, can't I? X squared plus 5x minus 84 is equal to 0. Now, I could go ahead and use the quadratic theorem, quadratic formula to come up with values for x, but I'm imagining that we're going to be able to factor this. So let's see what we end up with. Let me see. 84 is 4 times 21. Okay. 84 is 4 times 3 times 7. See, I'm doing a little bit of prime factoring here. Aha! I see something really nice. 84 is 12 times 7. That's the pair of factors that I'm looking for, 12 times 7. We're going to say x plus 12 times x minus 7 is equal to 0. Has to be a positive 12 because plus 12 minus 7 gives us this positive 5 of this center term that we're looking here for. Now we solve. What two possible values do we have for x? X can be either a negative 12 or a positive 5. Now, let's see. This says find the sum of the integers. Let's see. See which one works. Interesting. Okay. X is a positive 7. Have two possible choices. X can be 7, and the second integer would be 12. Or x could be negative 12, and the second integer would be negative 12 plus 5 is a negative 7. Doing this a little bit in my head, just following first integer, second integer, 7 and 12, or negative 12 is the first integer, the second integer is 5 more, negative 12 plus 5 is a negative 7. Let's see which works. Here is our original equation. X squared plus the quantity x plus 5 squared is equal to 193. Let's see what works. First, let's do 7 squared plus 7 plus 5 squared. Is that equal to 193? 49 plus 144 is equal to 193. So 7 and 12 both work. Now, what if we were to do the negative 12 and the negative 7? Sum of the first integer squared, the second integer squared. I don't even really need to use this formula, do I? Because it says you have to take the sum of their squares. So if you have 7 squared plus 12 squared, is that equal to 193? And what about a negative 7 squared and a negative 12 squared? Are those going to be equal to 193? Yes. We have 49 plus 144 for both of these. 49 plus 144 is equal to 193. 49 plus 144 is equal to 193. So you have two possible pairs of integers for this. Either you have 7 and 12, or you have negative 12 and a negative 7. So another example of how you can use quadratic equations to solve word problems. Do your best to solve these problems. There are a total of 20 problems. This is to my co-op class. Total of 20 problems. I've asked you to do a little bit more than half of them. This will take you a while to get through this section, but I know you can do it. If you get stuck, send me a text and I'll get with you. Otherwise, I'll see you on Friday.